Hello and welcome back to my Desynced tutorial series. Today, I'm going to show you the first part of a fully automated building-based mining network. So to start, we have a resource collection station here called a MineHead. And if you press the Tab key, you can enable an overlay that shows you that these three Autominers already have this MineHead set as their storage location. And since each Autominer has a personal transporter or a flipper, then as soon as a resource is mined, it gets immediately sent to this MineHead. Now, that's highly advantageous because as it flows, this is a constant steady stream. If these were robots, they would fill entirely and then dump their entire storage once they're full. And that sort of pulsatile loading can make the hauling network work a little harder. Let's see how it works. Now, as you see, one of my robots is dropping off new buildings. And I'm going to build a couple more myself. Now, this building was just dropped off, and it's already determined that it's supposed to talk to this Autominer. And you can see the beginnings of a flow network beginning to form. Let's see what happens as the other miners are also built. And I'm going to increase their priority just to make this go a little faster. So again, another Autominer is being dropped off by my miner shuffler. These Autominers are establishing their network connections, and as you see, as they come online, they might do a little bit of flickering and have some odd routing decisions. But on the whole, this will automatically build a network for you. Let's go ahead and take a deeper look at how the Autominer itself manages this logic. The Autominer has four basic functions. Each time it's placed down, it initializes itself exactly once per placement. Then, in a loop, it finds its best available path, it advertises its position within that path, and then it checks whether it's still useful. If it's not useful, it advertises itself as ready to be picked up and moved somewhere else. Now, all of these different parts of this network use the same signal type and just differ in their signal value. So all of the things that move OR around will use OR as their signal type. That means that I need to have some magic values to signal different types of signals, if that makes sense. So in this specific case, the values 10,000 to 10,200 are reserved for the MineHead, and the value 12,000 is reserved to indicate that this miner is currently useless. Let's take a look at initialization. The first thing it does is check to see whether it already knows what sort of resource it's supposed to use. So it checks value P5, and if that is not already a resource type, then it looks for the nearest resource. It gets its type, and it sets that to its resource parameter. It then sets that to infinity number with the set number, and that's what tells us what we're actually going to be mining. Now, there's a little bit of a difficulty in the program here that I want to call out pretty specifically, and that's this instruction right here, SetToComponent. Now, this is a bug in the code, and I want to show you how to fix it. So right now, as written, this will only work if you're using a miner. So what it does is it finds the miner in slot 1 and it tells it to mine whatever resource it is that you've indicated in P5. But if this is not a miner, if it's a laser miner, this won't work. And so the correct way to handle that is with register linking. So actually, what we do is this is the command that's used to set that resource, and then that's linked externally. And to see that, we take our resource and we tie it to our node here, and that is actually how that is going to work. And then I can go ahead and get rid of this incorrect piece of code. The next thing that happens is that we set up our initial signal to say that We're a miner. We're somewhere in the middle of the pack, and we're ready to be used. We replenish our liveliness counter, which just says that I have 100 ticks or 100 updates to prove my worth before I'm available for harvest. Now, the branch that we missed is in the case where this is initialized absolutely nowhere near a resource field, which happens very rarely. It instead advertises this down arrow, which in my game sets up a robot to go ahead and fry that building entirely. Moving on to the main loop, the first thing we do is to figure out where we are in the chain. This is done by looking at all of our nearest neighbors, seeing where they advertise themselves in the chain, and making our local decisions based on that. We're using the signal register to indicate where we currently think we are. Low values of signal indicate that we think we're closer to the head. High values of signal indicate we think we're farther away from the head. And our general strategy here is to lock into low values aggressively and to float to higher values conservatively. Let's see how that works. We're going to null out our values and initialize, and then we're going to do a LoopEntitiesRange with range 1. The reason that we do this is just a little bit of speed optimization. Looping over all of the entities within range 1 can only return up to 9 entities, maybe more if there's something flying overhead, but it should only return the 9 buildings or 9 objects nearby, which is much faster than evaluating all of the objects in the map that are advertising the signal or crystal or sand or whatever. Of those 9, we want to eliminate ourselves because that's going to be a bit confusing. We're going to take out anything that is less than 1, and we're only going to look things that are exactly 1 unit of distance away. Read the signal and make sure that it's actually talking about whatever it is that we care about, be that ore, sand, etc. We're going to use our magic values to ignore anything less than 10,000. 10,000 is and below is dedicated to the requester network. We aren't doing the requester network for this, so it is completely irrelevant to us. And the other magic value we have is that the values 10,000 to 10,200 are dedicated to MineHeads and their communication to other units. So if we see something that's between 10,000 and 10,200, we're going to pretend that we saw the value 10,200 by saturating up to it. Then we have a little bit of logic that's just dedicated to keeping track of what's the highest thing we've seen, what's the lowest thing we've seen, and if something is dead, or maybe dead is a violent word, something is indicating that it's no longer useful, we'll ignore it with this ignore anything over 12,000. Once we have a good understanding of what the best value and what the worst value is in our local neighborhood, we're going to set ourselves to link to the best thing that we saw, right? That's the closest, and the best that we can do is 1 away from the closest. And so then we're going to advertise ourselves as 1 worse than whatever we're linking up to. This will also allow it to generally float upwards if it doesn't have a stable connection. If, let's say that we are not yet attached to a MineHead, or we are searching in a value space that's too low, this will slowly float up 1 at a time each time it goes through its loop until it finally finds its position within the network. If something is formed quickly and jumps in the middle, this value will slam to equal it very quickly, and that will propagate with speed 1. And the last thing we do is we check to see whether or not we're still a useful device. So if we have items in our storage, or if we have any resources that are within range 1, or if something else is linking to us possibly, then what we're going to do is make our liveliness counter back to 100, and we're going to allow that to say, hey, we are currently useful, do not harvest. If none of these conditions are true, we're going to decrement our liveliness counter by 1, and eventually that will go down low enough that we will set our signal to, 12,000, to indicate that we're no longer useful. And let's take a look at that in code here. So to close out, let's just review these concepts one more time by taking a look at this relatively old OR patch. Now this used to include OR all the way out to here, and it started all the way over here. And over time, it's automatically filled in to take advantage of those things. And some of these aspects have already been harvested. I've intentionally added this kind of useless appendage here to show that it's slowly being harvested away. And you can see that because it's being advertised as unit 12,000. And this miner shuffler is taking it and moving it over to the new OR patch. You can also see that as these filled in, it's automatically formed what I call a pincer claw network around this. Now, let's just take a quick look to see what happens if I artificially break this network here. Right now, the bifurcation point is here, but if I tell this thing artificially to say, no, I want you to take out this building here, let's watch how the network heals itself. So it's taken out. These values begin to float upwards, and you can see that it's already patched around itself by coming out this way. If you have any questions, please feel free to comment. I hope this has been interesting. Have a great night. And a tiny bit of errata here. It turns out that my code to check whether it was already looking at a resource type was actually looking for a specific resource entity. So the update here is to check the resource for a closest entity of that resource. Then I can check to see the resource type and see if it's a resource, and that is how I can continue on there. Sorry about that all.